Section 430.145b of the National Electrical Code addresses the requirements related to the distance between a motor and its terminal box. Understanding this section is crucial for ensuring compliant and safe motor installations. This section of the code focuses on the placement and accessibility of the motor terminal box. The terminal box houses the connections between the motor windings and the external power source or control circuitry. It is essential that the terminal box is readily accessible for inspection, maintenance, and repairs. The NEC mandates specific clearances and working spaces around electrical equipment, including motor terminal boxes, to allow qualified personnel to perform these tasks safely and effectively. While the exact distance requirement between the motor and the terminal box is not explicitly defined as a specific numerical value, the code emphasizes the need for accessibility and working space. The installation must comply with the general requirements outlined in Article 110 of the NEC, which covers working space about electrical equipment. This means that there must be sufficient space around the terminal box to allow electricians to safely access and work on the connections. Factors that influence the allowable distance or placement include the size of the motor, the voltage level, and the presence of other equipment or obstructions in the vicinity. For instance, larger motors might require larger terminal boxes and more working space. Similarly, higher voltage installations may necessitate greater clearances to prevent electrical hazards. In addition to accessibility, the NEC also addresses the protection of the motor terminal box and its connections. The terminal box must be suitable for the environment in which it is installed. If the motor is located in a damp, wet, or corrosive environment, the terminal box must be rated accordingly to prevent moisture or contaminants from entering and damaging the connections. Furthermore, the conductors entering the terminal box must be properly protected from physical damage. This can be achieved by using appropriate conduit cable or other protective measures. The NEC also specifies requirements for the grounding and bonding of motor circuits and equipment. The motor frame and the terminal box must be properly grounded to provide a low impedance path for fault currents, which helps to minimize the risk of electrical shock. Grounding conductors must be sized and installed in accordance with the NEC requirements. Furthermore, the connections within the terminal box must be made using approved methods and materials. Wire connectors must be properly sized for the conductors being used, and they must be securely tightened to ensure reliable electrical connections. The NEC also addresses the identification of motor circuits and equipment. Motor disconnect switches and control equipment must be clearly labeled to indicate the function and the motor that they control. This helps to prevent confusion and errors during maintenance and troubleshooting. It is essential to consult the latest edition of the NEC and any applicable local codes or regulations to ensure compliance with all requirements for motor installations. The NEC is a comprehensive document that is updated regularly to reflect changes in technology and best practices. In addition to the general requirements outlined in Article 430 and Article 110, other sections of the NEC may also be relevant to motor installations. For example, Article 300 covers general wiring methods, and Article 310 covers conductor ampacity. It is important to consider all applicable requirements when designing and installing motor circuits. Some specific considerations for the distance between the motor and the terminal box include ensuring that the conductors are not subjected to excessive strain or bending. The conductors should be routed in a way that minimizes stress on the connections and prevents damage to the insulation. It is also important to consider the thermal environment in which the motor and terminal box are installed. Motors can generate significant heat, and the terminal box must be able to withstand the operating temperature. The NEC specifies temperature ratings for conductors and equipment, and it is important to select components that are suitable for the intended application. Furthermore, the location of the terminal box should be chosen to minimize exposure to sunlight, moisture, or other environmental factors that could degrade the connections. If the terminal box is located outdoors, it should be protected from the elements by a suitable enclosure. The size of the terminal box should be adequate to accommodate all of the necessary connections and wiring. The box should not be overcrowded, as this can make it difficult to work on the connections and can increase the risk of overheating. The NEC provides guidelines for box fill calculations, which help to ensure that the box is large enough to safely accommodate the conductors and devices. In addition to the NEC, other standards and guidelines may also be relevant to motor installations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for motor dimensions, performance, and safety. These standards can be helpful in selecting and installing motors and related equipment. It is also important to follow the manufacturer's instructions for installation and maintenance of motors and terminal boxes. The manufacturer's instructions provide specific guidance on how to properly install and connect the equipment, and they may also include recommendations for maintenance and troubleshooting. Proper motor installation is essential for ensuring the safe and reliable operation of electrical systems. By following the requirements of the NEC and other applicable standards and guidelines, it is possible to minimize the risk of electrical hazards and ensure that motors are installed in a manner that complies with code requirements. Remember to always consult with a qualified electrician or electrical engineer for assistance with motor installations, especially in complex or critical applications. These professionals have the knowledge and experience to ensure that the installation is performed safely and in accordance with all applicable requirements. The NEC is not a design manual, and it does not provide all of the information necessary to design a complete electrical system. It is important to use sound engineering judgment and to consult with qualified professionals to ensure that the system is safe and reliable. Understanding and adhering to Section 430.145b in conjunction with other relevant NEC articles is vital for safe and compliant motor installations. Proper planning, careful execution, and regular maintenance are all essential for ensuring the longevity and reliability of motor systems. The NEC also addresses the use of flexible cords and cables for connecting motors. In general, flexible cords and cables are not permitted for permanent wiring, but they may be used in certain applications, such as for connecting portable motors or for providing flexibility in motor connections. The NEC specifies the types of flexible cords and cables that are permitted for use with motors, and it also outlines requirements for their installation and support. It is important to select flexible cords and cables that are suitable for the intended application and to install them in accordance with the NEC requirements. When using flexible cords and cables, it is important to ensure that they are properly protected from physical damage. The cords and cable should be supported in a way that prevents them from being stretched or strained, and they should be protected from abrasion and other forms of wear. The NEC also addresses the use of strain relief devices for flexible cords and cables. Strain relief devices are designed to prevent the conductors from being pulled out of the connections, which can lead to electrical hazards. When installing strain relief devices, it is important to follow the manufacturer's instructions and to ensure that the devices are properly tightened. The NEC also addresses the use of overcurrent protection for motor circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the motor and the circuit conductors from damage caused by overloads and short circuits. The NEC specifies the types and sizes of overcurrent protection devices that are permitted for use with motors, and it also outlines requirements for their installation and coordination. When selecting overcurrent protection devices, it is important to consider the motor's full load current rating, its starting current, and its duty cycle. The overcurrent protection device should be sized to protect the motor from damage without causing nuisance tripping. The NEC also addresses the use of motor controllers. Motor controllers are devices that are used to start, stop, and control the speed of motors. The NEC specifies the types of motor controllers that are permitted for use with different types of motors, and it also outlines requirements for their installation and operation. When selecting a motor controller, it is important to consider the motor's voltage, current, and horsepower rating, as well as the application requirements. The motor controller should be sized to handle the motor's starting current and to provide adequate protection against overloads and short circuits. The NEC also addresses the use of disconnecting means for motor circuits. A disconnecting means is a device that is used to disconnect the motor from the power supply. The disconnecting means must be readily accessible and capable of being locked in the open position for safety during maintenance and repair. The NEC specifies the types of disconnecting means that are permitted for use with motors, and it also outlines requirements for their installation and location. When selecting a disconnecting means, it is important to consider the motor's voltage and current rating, as well as the location of the motor and the accessibility of the disconnecting means. The disconnecting means should be located within sight of the motor controller and the motor, unless it is lockable and tagged in accordance with the NEC requirements. The NEC is a complex and comprehensive document that covers a wide range of electrical topics. It is essential to consult the NEC and other applicable standards and guidelines to ensure that electrical installations are safe and compliant. Remember to always consult with a qualified electrician or electrical engineer for assistance with electrical installations, especially in complex or critical applications. Section 430.145b serves as a reminder that motor installations require careful attention to detail and a thorough understanding of the NEC requirements. By following the code and using good engineering practices, it is possible to create safe and reliable motor systems that will provide years of trouble-free operation. Understanding the provisions of the NEC, particularly Section 430.145b, ensures that electrical installations are performed safely and correctly. This code section highlights the importance of proper planning, installation, and maintenance of electrical systems to prevent hazards and ensure compliance. By adhering to these guidelines, electricians and engineers can create safe and efficient electrical environments.